Let's start motion. So we are going to discuss motion in 1 dimension, 2 dimension and 3 dimension. So let's start with motion in 1 dimension. So let's take an object M moving in a particular direction with velocity v. Now it is possible to align velocity of this component in a global coordinate, which is x and y. So we can say that this object with mass m moving in x direction with velocity v, and as long as motion is in a straight line, that means following the x-axis, we call it motion in 1 dimension. Now what is position and displacement? For example, again take a coordinate system. This is origin, this is x-axis, y-axis. So let's say object in the beginning is at a point A, which is at a distance x1 from the origin. So OA represents position vector of the object at A. If this object moves from A to B, so now the distance of B from origin is x2 and the position vector becomes OB, and the distance between A to B is displacement. So we can write displacement equals A to B, which is OB minus OA, that means x2 minus x1. So that's how we define position vector and displacement in case of 1D motion. This could be even extended for 2D and 3D. So if position is somewhere here, that means we are now moving in xy plane, not only in x direction. So this could be my position vector. It goes to A to B, let's say this one. So the new position vector is O to B, and the displacement becomes A to B in a plane xy, where one component is in x, another component is in y. So this is x component, this is y component. So that's how it could be represented in case of 2D and 3D. Let's now discuss about velocity and speed. Let's say what is velocity and what is speed. So we write average velocity equals total displacement by time taken. So for example, again let's say A and B. So the displacement is, total displacement is AB. It could be even a path like this. So between A to B, the object is going in this path, but the displacement is the shortest distance, so it is AB, and the time taken, let's say T. So AB by T. Since we are taking displacement, which is a vector quantity, so velocity comes as a vector quantity. It could be also represented as delta x by delta t. So basically this is nothing but delta x distance and the time is delta t, and this gives us average velocity. But when delta t tends to 0, limit delta x by delta t becomes dx by dt, and this gives us instantaneous instantaneous velocity. Now let's look at what is speed. So the speed is we say speed equals total distance, and distance is not a vector quantity, so the total distance by time taken, and hence a speed becomes a scalar quantity. So in this case ACB, so the distance could be ACB divided by time taken delta t will give us speed or average speed. Now let's move on to the next thing. What is acceleration? So acceleration is called to, acceleration represents rate of change in velocity. So let's say if we represent acceleration as a, so we can say velocity is v with the time t. So dv by dt is acceleration. In a graphical representation, let's say on this side we are representing velocity, this side we are representing time. Let's say initial velocity v1, final velocity v2, and time taken is delta t, which is t2 minus t1. So we could say that average acceleration equals final velocity minus initial velocity by time taken, which is t2 minus t1, which is again nothing but dv by dt.